Now we're going to add, subtract, and multiply radicals. All right, to be able to add radicals, they have to be like radicals. Just like when you add with polynomials, they have to be like. So if I have 3x squared plus 7x squared, I can add that and get 10x squared. If I have 3x plus 4x plus 5x squared, I can add these two and get 7x plus 5x squared. But I cannot add these two. It's the same thing with radicals. Radicals have to have the exact same number under the radical, and it has to be the same index number. So this is the square root of 3, and the square root of 3 is like seeing 5x plus 7x. I can do that. So I have, when I simplify this, 5 plus 7 is 12 onto the square root of 3. All right, now, same thing here. These are both the square root of 2. So negative 3 and a positive 4 is a positive 1. We don't typically write 1 onto the square root of 2, just like we don't write 1x. We write x. So here I would write the square root of 2. All right, now what I have to do when they're not like is I have to see, can they be simplified to be like? So I'm going to have to take these two and simplify them all the way down. So this is 2 times 81, and this is 9 times 9. All right, and it takes 2 the same number to bring one out. So 3 times 3 is 9 onto the square root of 2. I'm going to go up, and I'm going to do the next one. This is 2 times 16, 16, 2 times 8, and 8 has 3 2's. All right, it takes 2 of the same number to bring one out. So here we are. This is 4, 2 times 2, which is 4 onto the square root of 2. So minus 4 to the square root of 2. These two could be made to look like. So now I can put them together. And 9 square roots of 2 minus 4 square roots of 2 is 5 square roots of 2. And that's my answer. All right, these are 4th roots. And we just got through doing this one. So on the last slide, see how 32 had 5 2's? So I'm just going to go ahead and write that down and save myself some trouble. So 2, 2, 2, 2, 2, 5 2's. And 162 we had just got through doing. And it had 4 3's and a 2. So we're going to write that one out with 4 3's and a 2. All right, this time it takes 4 of the same number to bring one out, so I can bring out 3 onto the 4th root of 2 minus, same thing, it takes 4 of the same number, so 1, 2, 3, 4, so 2 onto the 4th root of 2. Now they are still like, they happen to still be like. See how they both have the 4th root of 2? All right, so 3 4th roots of 2 minus 2. 3 minus 2 is 1. So this answer is the 4th root of 2. Got to do the same thing again. Now this one is simplified down, thank goodness, right? And we know that 32 from the other problems has 5 2's. So when you know something like that, there's no need to continue to do the same factoring tree over and over and over again. 192 is 2 times 81. We may have done this one even on another problem, but right now I don't remember. Oops. You get into the habit of making all those lines and you just keep making them. Okay. Now, this is 4 onto the 6th root of 3. It takes 4 of the same number. All right, watch this right here. See that number there? It's called a multiplier. Don't forget that you have it. That's a mistake that I make all the time. So don't forget you have it. I have a 2 on the outside already, and it takes 4 of the same number, so there we are. There's a 2. So it's 2 times 2 onto the 4th root, and then I've got a 2 left. All right? So I currently have 4 onto the 6th root of 3 plus 4 onto the 4th root of 2. Now I'm going to go back up and finish this one. It takes 6 of the same number to bring one out. Do I have 6 of the same number? No. So I did all that work for nothing because I can't put it together with anything. So this is just 3 onto the 6th root of 192. Now, can I put anything together? No. Sometimes you do all that work and you can't put a thing together. This is the 6th root of 3, 4th root of 2, 6th root of 192, and nothing can be combined. But you do still have to simplify your answer. So we simplified this part now. You always have to simplify your answer, even if nothing goes together. All right, let's do this one. And we don't know what's going to happen. This is going to be 10 times 32, and we already know that 32 is 5 2s. So we're going to skip straight to that. All right, that one is simplified. We're going to come over, we're going to factor tree this. So 5, why am I using 5? Because the number ends in 5. 5 goes into 13 twice, and 5 goes into 35 7 times. All right, now, let's go back and let's work these problems. So this is negative. And I need 3 of the same number to bring one out. So I've got 3 2s, 3 2s. I'm bringing a 2 out twice. So 2 times 2 onto the cube root, and then I have a 5 left. Uh-oh, I've got a like term. Minus 5 onto the cube root of 5 from up here. It didn't need to be simplified any. And then I'm going to come over here, and it takes 3 of the same number to bring one out. And there we go. We've got a 3. So this is plus 3 onto the cube root of 5. Now, do we have similar or like terms? Yes, we do. We've got a cube root of 5, a cube root of 5, and a cube root of 5. So this is negative 4 minus 5 plus 3, just looking at the numbers on the outside. Negative 9 plus 3 is negative 6 onto the cube root of 5. This one simplified down beautifully into one term. All right, now we're going to multiply. When we multiply, this is what you do. You multiply any numbers that are on the outside. So you multiply outside numbers with outside, and inside numbers with inside. Okay. So I don't have any numbers on the outside here, but I do have them on the inside. So 4 times 16, I honestly can do this. Who cares what 4 times 16 is? And then just break it down. And we know that 8 is 3 2s. Okay. So I need 3 of the same number to bring one out, and looky. 1 2 3, 1 2 3. Everything came out. So I've got 2 times 2 that came out. And my answer is 4. Nothing is left inside, so do not write the radical. This is what I've seen students do in the past. 4, cube root, they don't write nothing down. No, that's not proper. Don't do that. It's just 4. All right, now, outside with outside, inside with inside. This hasn't understood 1. This hasn't understood 1 on the outside. And I'm going to distribute just like I would here. just like you do with polynomials and you distribute, I'm gonna distribute. So 4 times 1 is 4. 15 times 5 is 75. Then I'm gonna go 4 times -1, -4. 15 times 6, 90. Then I'm going to simplify. 3 times 25. 10 times 9. All right, now, don't forget your multipliers. 4 times 5 onto the square root of 3 minus 4 times 3 onto the square root of 10. So my answer, because 2 times 5 is 10. So my answer here is 20 onto the square root of 3 minus 12 onto the square root of 10. Now I cannot put these together because they are not like. I've got the square root of 3 and the square root of 10. So they don't go together, and I'm just done. Again, 3 times 1, -3. 2 times 10 is 20. -3 times -2, positive 6. And 6 times 2 is 12. Now what I have to do is I have to see if these are like. So I begin with the factoring tree again. This one is -3 times 2, which is -6, onto the square root of 5. This one is 6 times 2, which is 12 on the square root of 3. And I just stop there. If they could be put together, I would put them together, but they cannot. All right, we have a variable here. This is the same as doing this. When you do this, and then you take and you multiply those two. It's the same process. So I'm going to take -8 times 4, which is -32. I'm going to take -8. Oops. Yeah, it's got an understood 1. So negative and then square root of 2x because I have no inside here. And that's fine. That's just the way it worked. Remember, outside with outside, inside with inside. Now I only have an outside and an inside. So this is 4 square roots of 2x. And then this is the square root of 4x squared because 2 times 2 is 4 and x times x is x squared. Now, -32. These two are like because they're both square root of 2x. So -1, positive 4. It's positive 3 on the square root of 2x. Okay? Square root of 4 is 2. Square root of x squared. 2 goes into 2 one time with nothing left over. And that is my answer. I think. Okay, we'll do one more. 16 plus 8 square roots of 6 plus 2 square roots of 6 plus the square root of 36. Okay, 16. These two are like, plus 10 square roots of 6. And the square root of 36, y'all know that, is 6. So 16 plus 6 is now like. So I have 22 plus 10 onto the square root.